Hello, my name is Quentin Bertrand, and I will be explaining the chain rule today. So the chain rule is applied when we have a function a of x, which has multiple inside functions, such as here, where it's h of g of f of x. So it is used to find the derivative of this function a of x. So here we have a prime of x is equal to h prime, which is the first function, which we term prime, and then we keep the two inside functions, g of f of x, the same. So we have h prime of g of f of x. Then we multiply this by the second one, which is just one more inside from the original, g prime, and then we keep the very inside the same, so g prime of f of x. We repeat this step one more time with the final inside function, which is f. We have f prime, and then we just have x left, so f prime of x. So to solve a of x using the chain rule, which can be sometimes complicated, we have to understand a few essentials. The first of this I will refer to as f of x being ln of u of x. So already we can see that u of x is an inside function. So the derivative of ln to the u of x is simply 1 over u of x, which is us bringing down the inside function to the denominator here, multiplied by the derivative of this inside function, u prime of x. Then we have another essential where a is a constant to the power of u of x, the inside function. When we take the derivative of this, we'll get ln of a, thus natural log of this constant, multiplied by the original function, multiplied by, again, the chain rule aspect, the derivative of the inside function u of x, bringing down to here. And a must be a constant. A specific example to this more general rule is when we have a being e. So when we have e to the power of u of x. The derivative of this function is e to the u of x multiplied by u prime of x. The reason we don't need to have the ln of a is since a is equal to e and ln of e is simply 1, it can be omitted while still keeping this true. So let's apply the rules we just learned in this first example. So here we have a function f of x is equal to e to the 2x plus 3 to the 5x, and we're going to find f prime of x, or the derivative of this function here. So f prime of x is equal to the derivative of e to the 2x plus the derivative of 3 to the 5x. So here we should recognize that we have a constant to a power, but this constant is specifically e, which is why in the next step we only show e to the 2x multiplied by the derivative of the inside function. Here, since the constant is not e, we must remember that it is 3 to the 5x multiplied by ln of 3, which we have instead of a now. Then we multiply this by the inside function, 5x, its derivative. The final step is when we combine everything together. We have e to the 2x multiplied by 2, which is simply the derivative of 2x, plus 3 to the 5x multiplied by ln of 3 multiplied by 5, which is simply the derivative of 5x, the inside function. So in this second example, we're going to be using chain rule again just to solve a different type of problem. So here we have the function g of x defined as the third root of 1 plus tan x, which is the inside function, and we have to find g prime of x. So here we have g of x is equal to 1 plus tan x to the 1/3, which is just this rewritten differently in order to really highlight this power. So now we're going to find the derivative just by taking the derivative of the entire function, or d dx it. Now we have g prime of x is equal to 1/3 times 1 plus tan x to the negative 2/3, which is just us moving down this original 1/3 power to the front, and then subtracting it by 1 to get negative 2/3, which is just power rule. Then we multiply this by the inside function, or chain rule. Now we're going to rewrite this as g prime of x is equal to 1 over 3 times 1 plus tan x to the 2/3, since APs apparently do not like this negative 2/3, multiplied by the derivative of 1 plus tan x, which is secant squared x. And then finally, when we put everything together, we have g prime of x is equal to secant squared of x over 3 times the third root of 1 plus tan x, the whole thing squared. So in this third and final example, which is a lot trickier than the other ones. We're going to try to find dy dx. So we have y defined as x to the sine of 5x. So already we can tell we can't use the a to the u of x since x is not a constant in this case. So we have to determine a new method, and we're going to use something we saw before, which is ln to something. So we're going to take ln of both sides, so ln of y is equal to ln of this original, so ln of x to the sine 5x. Now let's take the derivative of both sides. D dx of ln of y is equal to d dx of sine 5x, since we can move down this exponent to the front when we have it within a log, multiplied by ln of x. So already we can see multiple chain rules appearing, such as 5x within sine, the x within ln, and a new one, which is a y within ln. So the y within ln, we still have the same idea, which is 1 over the inside, or y, multiplied by the derivative of the inside y, thus dy dx, which is equal to cosine of 5x multiplied by the derivative of the interior function, 5x, multiplied by the original ln x. So obviously this is a power rule, which we can see here. So the other side of the power rule would be plus sine 5x, or keeping this original function, multiplied by the derivative of the second, thus 1 over x, which we already learned. Then, since we only want dy dx, we're going to move this y, we're going to multiply both sides by y, thus this cancels out to 1, and the y appears here now. And we've already rewritten this as 5 times ln of x, since 5 is the derivative of 5x, ln of x, which comes from here, times cosine 5x, plus sine of 5x over x. Now, when we simplify everything, we turn the y into the original function, since we've already had y defined for us, and we get dy dx is equal to x sine of 5x, which is y, multiplied by 5x ln of x cosine 5x, plus sine of 5x all over x, since we distributed the x to this function in order to give them all common denominator and have a simplified answer. I hope after this lesson you have a better understanding now of the very important chain rule, and thank you so much for your attention, and also thank you for my dog for being in very little of the video. Here's Sparrow.